Chapter 10, Part 4 is a brief introduction to polymers. So polymers are large compounds that are made up of repeating units of what are called monomers, which are small building blocks, covalently linked together to form long chains. So these parentheses and the n is greater than 400 is saying that this is our monomer unit that is repeating, and it repeats at least 400 times. So this is quite a large polymer. The main difference between polymers and small molecules is that polymer chains are able to form significant entanglements. So literally meaning that they are tangled up together. Think of polymers as like a pot of spaghetti. If you don't have like oil or sauce in there and you try to pick up the spaghetti and extract one noodle, you really can't because they're all entangled together. This is what gives polymers their unique mechanical properties. So a lot of polymers have significant stretch to them, and that's because the individual polymer chains are not covalently linked together. Their entanglements are what keep them held together, but as you stretch, they are able to slide from each other without actually unentangling. So a couple common polymers over here are in this table. So you're probably pretty familiar with polyethylene, often symbolized as PET. This is just a repeating unit of ethylene, just two carbons over and over. You can also have polypropylene, which is a repeating unit of propylene. Notice that we're using the common names here. The common names are the ones that are most frequently used in industry, and polymers are one of the largest chemical industries in the world. So we're using industrial names here. The IUPAC names for these, again, would be ethene and propene. And you have a repeating unit of propane there. Styrene gives you polystyrene. This is styrofoam. So this has a benzene ring on it, and you can see the repeating carbons that were involved in the double bond. And then the benzene ring creates what's called a pendant group. So technically polypropylene also has a really small methyl pendant. A pendant is something that hangs off of the repeating polymer chain. And then another example is polyvinyl chloride, which is just a repeating unit of the commonly called vinyl chloride, which you can also call one chloroethene. So the reason that this is in the radical chapter is that a lot of polymers go through a radical polymerization. There are also some that use condensation chemistry, which is something that we'll look at later in organic 2. So this is not the only way to make polymers, but it is really common. So this typically starts with some sort of radical initiator, such as iodine, some halogen. And in the initiation process, the iodine reacts with a double bond, and you create an alkyl radical. That radical then reacts with another equivalent of the polymer monomer unit, and then it just reacts over and over until it either hits a radical from another polymer chain or finds another equivalent of iodine until it finds another radical, whatever that may be. The radical initiator propagates to create the organic radical. The reaction will continue until the radical is quenched. The end result is the repeating unit of the monomer. The main tricky thing about radical polymerizations is that because these are radical reactions and radicals are so reactive, a lot of times exposure to air or moisture can actually quench or end the reaction. Quench is the same thing as termination. And so since these are so sensitive, trying to produce them in controlled environments can be really tricky, and they often result in short chain polymers, which are never going to have as fascinating of mechanical properties as your longer chain polymers. Now this is just a really super brief introduction to polymers. I want you to know how polymers are made and kind of recognize these propagation steps and what a intermediate in the mechanism might look like. But obviously we're not covering polymer properties here. We're not talking about what makes a long chain, what makes a short chain, things like that. This is just an introduction to this concept.